So now that we've calculated the factorial of 4 manually, let's just go ahead and do a quick example of using a function to calculate the factorial. And so functions begin with the keyword argument function, followed by the name of the function. And then there's no parameter list in Bash. You just open your curly brace and then you start writing your function. So we'll initialize our factorial to 1, and then we'll say for x in 1, 2, and this is where we grab our first argument. So to grab our first argument passed to the factorial, we put $1. And so this way we can make our factorial a little more generic. And then you just continue as the previous example. And at the very end, you want to say echo fact. And to finish our function, we'll close the curly brace. So let's give it a go. Factorial of 4. And we see that's 24, just as we expected. So now I'm going to show you a cool trick to extract and replace the first occurrence of something on the previous line. This works really great for typos. But if we wanted to do the factorial of 5, we can just replace the 4 by saying caret 4 caret 5. So then when we hit enter, it replaces the value 4 with 5. And so you see it's 120. Just so you can see it again, we'll replace factorial with echo. And there you can see echo 5. If you're doing a lot of work in the shell and you forget what your function was, you can type declare f factorial, and we can see there it pumps to standard out the definition for the function. If you have so many functions that you can't keep up with it and you need to delete a couple, unset tac f factorial. So now if you type declare f factorial, we can see that it doesn't exist. So let's talk about some other math operations. If you ever need to convert binary to decimal, you can just echo to standard out, and inside of that subshell we're just going to pass the arguments of 2 and then pound and then the number we want to convert. So we're going base 2, so this is converting 1010, which is 10 in binary, and there we can see it's 10. If you want to print decimal to binary, you can use BC, which is basic calculator. So we'll say BC. And now I'm going to show you another trick. It's what's called a here file or a here string. And so it's just 3 arrows pointing towards BC. And then in a string quote, you put what you want to calculate. So we're calculating O base of 2. And we want to know what 10 is in base 2 or binary. And as you can see, it's 1010, and we know that's right because we just encoded it. If you want to print a number that's hexadecimal, and if you want to translate a hex value to a decimal value, you can use printf. Printf works like echo, but you have to give it a string format. So in here is our string format. And so decimal is %d. And then we'll follow that with a new line because it doesn't automatically include it like echo does. So we'll type 0xFF. And as you can see, that's 255 in hexadecimal, and that's correct. If you want to print decimal to hex, you can type printf and then our string formatter here, and we'll say x. And don't forget your new line. And we want to know what 10 is in hexadecimal, and that's A. If you want your values to be uppercase, you can use an uppercase X. So now that we've learned some basic conversions in the terminal, let's do a little bit of arithmetic. But before we do, I would like to talk about pipe. So pipe is a postfix delivery to an external command. So if you'll remember, postfix implies A, B plus, prefix implies plus A, B, and infix implies A plus B. So infix notation is what we're accustomed to in basic arithmetic, but pipe uses postfix. That has nothing to do with the math. That has to do with how the arguments are passed together. If that made no sense, don't worry about it. We're going to go over it right now. So using BC and echo, we'll say echo 1 plus 1, and we'll pipe that into BC. So this is where the prefix, infix, and postfix notation comes into play. We're taking the output from echo and sending it to BC. And as you can see, that's 2. An alternative, like we previously mentioned, is using a here string or a here file. So we can say BC here string 1 plus 1, and we get the same output. BC can do more than just basic arithmetic. Let's calculate the square root of 2. And as you can see, it's 1. While that answer is correct, it's not exactly precise. If you want to use long values, let's add a tac L to BC. And here you can see it brings out tons of decimal places. If you want to limit your decimal places, you can say scale equals 4, semicolon. You should be careful about rounding errors. For instance, it's easier to see if we do scale equals 6. And then we do it without a scale. You can see that there's a rounding error here. This 3 should be a 4. So if you only want a certain amount of decimal places, you'll need to use printf. And so we want to print a float, so that's %f. And if we want 6 decimal points, we put .6 in between the percent and the f. And don't forget your new line. So then we'll run a subshell with the command echo square root of 2 into BC long. And as you can see, that properly rounds. Bash isn't specifically meant to do intensive computation, and you'd be more well suited to pick up a different programming language if you're doing a computationally intensive project. So we talked about using a here string, BC long, and that's awesome, but what if we have too many values to put inside of a here string? Well, that's where we can use a here doc. So a here doc is 2 less thans followed by a flag, and our flag is going to be end of file EOF, and then you can say A 2 3 B 4 6 C 6 9. So if that's all you wanted to print, you put EOF and hit enter. And as you can see, it just spits it right back out to the console. If you wanted to send it to a file, you could do it like this. And then you just fill in your values. And so now if we print the contents of F1, cat F1, we can see it was stored in there. This is handy if you just want to insert something in a file really quickly and don't want to use an editor. So now let's talk about translation between format types. For instance, comma separated values to word separated values. So Bash has a handy built-in tool, tr, that translates characters. And it can do more than that. For instance, if we wanted to change the contents of file F1 from comma separated values into white space separated values, we could type tr and then tac d for delete, and then we'll delete the comma, and then we'll redirect standard in from f1.txt. And as you can see, it removes the commas. If you wanted to translate the comma separated values into tab separated values, you could do tr comma and then \t for the next one and send it f1. And as you can see, comes out tab separated. So let's store the contents of f1 into a variable for a little bit of manipulation. One thing you need to keep in mind is that tr does not modify the original file. So if we cat f1, we can see it's still comma separated values. So let's remove our commas and store it in a variable called matrix. So we can say matrix equals, and then we'll do a subshell, and we want the output of deleting the commas in the matrix. So then if you echo matrix, now we have a variable that we can manipulate in the bash shell. First, let's make our matrix homogeneous, which means that all the values are the same. Right now we have alphanumeric characters. We just want numeric characters. So we can say matrix equals, and then we'll do a subshell, and we'll do a translation operation. And we're going to translate A through C into 1, 2, 3. And we'll use a here string to grab at our matrix. So then when you echo matrix, you can see we have all numeric values. So let's do some manipulation on the matrix. What if we wanted to sum each row in the matrix? Well, the first thing we could do is translate the white space characters in between them to addition signs. So this isn't stored back in matrix, so we need to run a subshell and send it to basic calculator. So here's how you can do that. You say BC, and then we'll use our here string, and we'll run a subshell. And so the subshell is just the last command. So there's a sweet little trick you can do in the Linux Unix shell, and that's bang bang. The exclamation point is often referred to as bang. And so that will fill the subshell with the last command that was run. So if we hit enter, we can see it fills it out for us. If we hit enter again, we can see the addition operation is performed for each row. It's pretty handy. So now we figured out how to do operations on the rows. Let's figure out how to aggregate columns out of the matrix. So we can use the handy utility cut. So cut, and with cut you specify the delimiter tac d, and so the delimiter for our matrix is just going to be white space. And if you want the second field, you put tac f2, and we'll just send it our matrix. And if you echo matrix, you can see that that is indeed the second column. If you wanted the second and third, you can just put tac after the 2, and that will grab 2, 3, and if the matrix had 4, 5, and 6, it would grab those 2. Additionally, if you only wanted the first 2 columns, you can just put the tac in front of the 2, and there you see we get the first 2 columns. Now what if you wanted the first and third column but not the second column? Well, that's where awk comes in, and it's pretty handy. Definitely check out the man page for it. I'm just going to show you a quick example. So you would say awk, and then we want to have string, and then curly braces. So we'll type print, and just like our factorial function example, we'll say $1 to get the first column. And then we want some white space, so we'll use double quotes to fill that in. And then $3 to get the third column. And don't forget to send it to matrix. And as you can see, we get the first and third columns. So let's take a look at our matrix again. And we'll just clear up some screen space. Let's go ahead and change the 2 6's in our matrix to the value 2. And we'll do that with TR. And as you can see, the two values that were 6 are now the value 2. So what if we wanted to count all occurrences of 2 in our matrix? Well, one way you could attempt this is we could use awk. So let's say the pattern that we're looking for is 2. You can say awk, and then we'll use double quotes, and then backslash pattern that you're looking for, and then slash plus plus counter end print counter, and we're sending that our matrix. So if you're a little confused by this, that's okay. This is just to kind of show you a little bit of awk. There are actually better ways to do this, and we'll discuss some alternatives. But as you can see, it comes out with 3, and that's not correct. We know that there are 4 2's in our matrix. What happens is for each time awk encounters the pattern 2 on a line, it counts it and moves on to the next line. So the second column, it misses the last 2. This is a great opportunity to use grep. So I'm going to show you how to do that. A handy alias that I highly recommend using is alias grep equals, and then grep, but we always want to say color equals auto. So now when we grep for a pattern, which means get regular expression, and we send it our matrix, it highlights all of the 2's in our matrix. So if you wanted to count them, you can pass a tac-c flag. But you can see we ran into the same problem that we ran in with awk. On the second line, it encounters the first 2, counts it, and then continues on. So a way around this is just to make your matrix flat by translating each white space into a new line in our matrix. Had a parse error there. So if we do echo flat, we can see that all the values are now on one line. So if we run grep tac-c for our pattern, and then we send in the flat, we see we get 4, which is the correct answer. I don't want to dive too heavily into regular expressions, so I'll just show you a quick example. If we print out the contents of F1, we can see our original alphanumeric matrix. To count our values, we'd say grep tac-c, the pattern we're looking for, and then we'll send in our flat matrix, which is 4. And that's the correct answer. So let's talk about regular expressions for a little bit. I don't want to go too deep into it. It's its own micro language. I'll just kind of show you the ropes. So if we say grep and then parens and we say \d, that stands for digit. So if we send in f1.txt, it highlights all of our digits. If you wanted to find all capitalized letters, you can use extended grep by using a tac-e and then 2 square braces and a colon on each end, followed by your extended modifier. So we'll say upper. As you can see, it grabs all the uppercase characters. Grep isn't the only one that uses these extended modifiers. You could use tr, and we'll go upper, lower, f1.txt, you can see that it translated the uppercase characters to lowercase characters. So let's use a here doc to get another file. We'll say EOF and we'll send it to f2txt, and that doesn't exist yet, so we'll be creating it. So what are the numbers we want to put in it? Well, we'll put 1492, 007, lucky number 13, and we'll do 7 again. So type EOF and we're finished, and we cat F2, and you can see there's those values that we used the here doc for. So if we grepped for a digit in F2, it highlights all of them. And again, that's because I set color equal to auto. But what if we wanted to get 2 digits next to each other? \D. Well, you can see it leaves out the bottom 7, and when it reaches the second 7, it only grabs the first 2 zeros. So if you were to try to extract this using the regular expression, 7 may get left out. To kind of explain it a little more, we can do \D again for 3, and you can see it just grabs 149 out of the first line. So if you get tired of typing out \D, let's say you're looking for a phone number or something like that, you don't want to type /D for each digit. So what you can do is use extended regular expressions. So you can type grep tac E, and then if we want just 2, we can say D and then open bracket 2 close bracket. And we'll do that for F2. And you can see that simplifies our pattern that we're matching on, but it still doesn't solve the problem. What if we just wanted to grab 07 on the second line and not 00? Well, you could say lines beginning with 2 or more by using a comma. Or you could say I only want lines with 2 or 3 digits. But again, we're still running into that problem where it's only matching the first 3 digits of the line. So the way around this, and I'm going to clear the screen. So you can say I want it to match the first 2 digits by explicitly placing a caret symbol. And you see that's no real change in what we wanted. But here is another modifier you can use. You can throw in a $, and that says I want 2 digits that are next to the end of the line. And as you can see here on the first and second line, it only greps on the last 2 digits. If you wanted to grab 2 only, then you can throw a caret and a $sign on there. So what this is saying is at the beginning of a line, match any 2 decimals and then end the line. So we'll run this, and you can see it only matches 13 because 13 is the only one with explicitly 2 digits on the line and then ending a line. So that was a nice little introduction to grep. Let's talk about sorting now. So if we cat F2 to standard out, you can see that the values aren't sorted. So Linux has a built-in utility called sort. So if we say sort f2.txt, it sorts it. But when you examine the output, it's not exactly what you expect. The way it sorted the values is by the value of the character and not the numeric value. So if you want to sort on the numeric value, you can put a tac n here. And so now you see 007, 7, 13, 14, 92, and that's correctly sorted. As you can see, we have duplicates though, 007 and 7. Even though they don't have the same amount of characters, numerically they are equivalent. So if you want unique values, you can put U as a flag. And there we can see it eliminated the second 7. So we'll talk more about sorting in a minute, but now we need some data to mess with some more advanced flags and sort. So let's talk about brace expansion. So we can say echo, just like in our for loop, we can say 1 to 3. In this case, I'm going to say A to C, and then we'll add another brace, 1 to 3. And so this brace expansion is very reminiscent of the Cartesian product. So it goes A1, A2, A3, B1, so on. A Cartesian product may look a little bit closer to this. And you can fool around with basic calculator if you want. But now we're going to use brace expansion to create some inversely sorted key value pairs. So we'll say echo C to A, and that's decreasing, and then 1 to 3, that's increasing. So now you see C1, C2, C3, B1, B2, B3. And let's just go ahead and add a comma in here. Excuse me. You need to not leave white space. There we go. C1, C comma 2, C comma 3. So now we can pass this value as a here string, and using techniques we learned earlier, we'll use bang bang to get the previous line. And we'll send that to translate, and we'll translate the spaces to new lines. And then we'll just keep on going in the chain. We'll say tr comma to a white space, and then we'll send that to f3.txt. And when I press tab, you can see it expands out to the full expression. So now if we cat F3, you can see the values are now stored in ascending order by numeric and descending order by alphabet. So if we type sort F3, we can see that it's sorted on the first value in the columns. So A, B, 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 C, 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 and that worked out great. And it wasn't a numeric sort. But what if we wanted to numerically sort on the second column? Well, the way you could do that is doing a numeric sort, and then we type K2 for the second column. So now when you run that, you can see that the values were sorted. The numeric values are 111, 222, 333. So this can come in handy when you're trying to sort data. Let's do another example of brace expansion to learn how to filter out unique values. So we'll say echo, and then 0, and then our expansion 0 to 2. And so if you type this, it'll put 0, 0, 0, 1, 0, 2. We'll just go ahead and run it. See? So we want that value, and we also want some duplicates. So we'll put a white space and a 0, and we'll do 2 to 4. So we know that there's going to be overlapping values. Yeah, so you can see 0, 0 happens a couple times, 0, 1 happens a couple times. So if you wanted to get unique values, we could send our lists with duplicates into tr and translate the white spaces in the new lines and send that to unique. But as you can see, it doesn't really work as expected. Matter of fact, we still have multiple 0, 0s you can see in the first 3 lines. So what happens is you need to sort the values before you send them to unique. And as you can see, it brings out only unique values. But it's kind of redundant, in my opinion, when you can just use sort, tac, and u, and you get the equivalent output. But I felt I would be failing you if I didn't mention unique. So what if we wanted to add a column to a file? Well, let's just go ahead and cat f2.txt, and we can see we have a single column of data. So let's create a variable called column, and we will fill it with a subshell using a here doc. So that's 2 less than signs. So you'll say A, B, C, D, and that's 4, so we'll say EOF. and then we have to close our command substitution. So if you end the command substitution and end a file on the same line, you'll run into problems parsing it and it'll spit out an error at you. So let's go ahead and echo our column, and as you can see, the value's there as we expected. So how do we add this column to F2? Well, that's where the paste command comes in. So if we type paste f2.txt and then attack, you can see that it adds our column to the values. So it has F2 column, F2 column, F2 column. If you wanted to add the column in front of the values, you could do it by moving the tac in front of F2. So the position of the parameters is how paste recognizes which column the data goes into. So now you can see column F2, column F2, column F2. If we wanted to surround F2 with the same values on both sides, you can put tac F2 tac. And as you can see, it's A 1492, B, C 007, B. If you wanted to surround the column with values of F2, you would do paste f2.txt tac f2.txt and then send your column. So that's how paste works.